Okay, in this lesson we're going to be looking at another counting method called combinations. So this is a little bit different what we've been doing in class so far, which we've called permutations. So in permutations, the order of objects mattered, right? Or the order of letters mattered, where ABC was a different count as BCA, which was a different count as CAB, okay? Or when we were looking at putting people on a team, you could be the same 5 people on the team, but if you were in a different position, that counted as a different count, okay? What we're going to look at today is specifically something called a combination, where, again, you're looking at elements being included or not included, but the order of them doesn't really matter, okay? So it's either like you've made the team or you're not on the team, or you're there or you're not, right? You're included or you're not, right? But the order doesn't really matter, okay? So the combination formula is very similar to the permutations formula in the fact that it uses factorial. So again, there's this idea of there's so many things to choose from, which we'll call n, right? And you're only selecting so many of them out of that, and that again is still considered r. But you're saying to yourself, you know, in this particular situation, the order that I choose them or the actual placement of them doesn't really matter. It's either they're there or they're not, which means we're going to use a combination here instead of a permutation. So we use NCR instead of NPR. This is again a button that's on your calculator that you just plug in the N value, the NCR button, the R value, and then hit equals. But the formula is again very similar, in which you have this N factorial, right? The total number of options if you used all of them. But now you're saying, look, I'm not using all of them, I'm only using some, so this is where that N minus R factorial comes into play, and that was the exact formula for the permutations, but because the order of the R things that you've selected doesn't matter, it's that idea of, well, we have to divide by the identical objects, because ABC, when in a combination, is the same as CAB, so any rearrangement of those R things must also be kind of discluded, so you're dividing by that value, so that's where that dividing by R factorial comes from. Right, so kind of a combination of our permutations lesson and then our permutations with identical objects. Okay, so that's the formula. You'll also see it written here as NCR. In the textbook, you also might just see these big brackets and then N on the top and R on the bottom. It's still the same idea. It's just a different notation. Okay. So again, another way to kind of give you an example here is if we look back at our flipping 2 coins example, right? Coin 1, your options are either a head or a tail. In coin 2, again, your options are either heads or tails. And if you look at all the possible combination, it can either be head, 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 tail, tail, head, and tail, tail. Okay? With our permutations, the order mattered, and a head followed by a tail is a different situation as a tail followed by a head. But if something was just asking how many ways can you get one of each, then head, tail, and tail, head, they're essentially the same thing. Okay? So when you're looking at the different possibilities, it's either you get both heads, both tails, or one of each. And that just gets counted essentially as one. Right? So even though we see them as 2 things, if it's a head then a tail versus a tail then a head, if we're dealing with a combination, it's just, well, is it one of each? Okay, well then it's just one option. Okay? So that's kind of counted as one thing. All right, and we're just going to kind of run through some examples here. So here we have a restaurant serves 10 flavors of ice cream. Danielle has ordered a large sundae with 3 scoops of ice cream. How many different ice cream combinations does Danielle have to choose from if she wants each scoop to be a different flavor? So we do have options, and we have a certain number that we're choosing between. So there's a total of 10 options to choose from. So our N value here is 10. From those 10 options, we're only choosing 3, right? We're putting 3 scoops on it. So our R value here is 3. And now we just really need to discern, is this a permutation or is this a combination? Does the order matter? And if you think about this, it really doesn't. You either have that scoop of ice cream or you don't. Chocolate, vanilla, and strawberry is the same as strawberry, chocolate, and vanilla, right? It's either in the sundae or it's not in the sundae. Okay, so that means we would use, in fact, a combination here. We're looking at combinations. So we would do our NCR formula. So this is 10C3, right? And again, you could just plug that in on a calculator, or if we wanted to reason with the formula again, it's N factorial, so in this case 10 factorial, divided by R factorial, right? So take all the counts that would be the same 3 things but in different orders, and we're going to divide it by that because it's the same option, right? And then 10 minus 3 factorial here, right? Because again, we're not having all 10 of them, we're only having 3 from the 10. Okay, so again, if you wanted to reason with that, that's your 10 times your 9 times your 8 times your 7 times your 6, all the way down until you get down to your 1, okay? Here, this is your 3 times your 2 times your 1. 10 minus 3 is 7, so 7 factorial would be your 7 times your 6 times your 5 times your 4, all the way down to your 1. So you should see that the 7 downs cancel, so 7, 6, the 5, 4, 3, 2, 1, 3, 2, 1 there. So what you're left with here is 10 times 9 times 8 divided by 3 times 2 times 1. And then you can evaluate that, being sure to evaluate the numerator completely. So 10 times 9 times 8 being 720 divided by 3 times 2 times 1, which is 6. And 720 divided by 6 is 120. So with 10 scoops available, okay, and you're putting 3 on there, you actually do have 120 choices, right? So from 10 ice creams to choose from, and then selecting 3 of them, you have 120 options, okay? So 120 different ice cream combinations for the sundae. All right, so let's take a look at another example here. So, Tanya is the coach of a pole push team that consists of 9 players, 5 male and 4 female. So these are the total number of people that are on our team. We have 9 people on our team, 5 of them males, 4 of them females. In each of the competitions, it's teams of 4 competing against other teams of 4 to push their competitors out of a circle. That's the idea of this pole push. The team that's successful in pushing the other team out is the winner. Okay? How many different 4-person teams does Tanya have to choose from for an all-male competition? So again, this is key. So it's a 4-person team, and it's an all-male competition. So because it's an all-male competition, we've kind of been restricted here. She doesn't have the choice of all 9 players from her team. She only has the choice of picking her males from her team. And from her team, there are only 5 males. So our N value is 5. Okay? And from those 5 people that she has to choose from, she needs to pick 4. So our R value is 4. This is, again, an example of a combination, because this isn't something where you're assigning each person to a different position. You're either on the team or you're not on the team. So the same 4 people just picked in a different order is the same thing, because there's no hierarchy or position associated with it. It's just you're there or you're not. So this is why a combination is used here. So again, this is how many there were to choose from, 5. We're choosing from that. It's just a combination from 4. So it's 5C4. Okay, so again, if we went through our formula here, it's 5 factorial divided by 4 factorial times 5 minus 4 factorial, right? So this is going to be your 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1 factorial, which is just 1. And what you'll see here is that your 4 down will cancel, and, well, that 1 just cancels with one of them, and you're left with 5 over 1, which means there's only 5 different teams that she can choose. Okay? So she has 5 different 4-person teams. So there are 5 different 4-person male teams possible. Okay? So again, carefully reading of these questions is key to ensure that you understand what restrictions you've been given, and then whether or not it should be a combination or a permutation. Okay? So same context, it's still this 9-person team, 5 males, 4 females, but now we're going to be given a different condition. How many different 4-person teams does Tanya have to choose from with 2 males and 2 females for a mixed competition? So what we need to look at here is, okay, well, we need to choose the males, and then we need to choose the females. And notice that I've used the word and, which means we're going to be multiplying those situations. So let's see, how many options are there for choosing male teams, and how many options are there for choosing the females for the team? Okay, so again, remember that there are 5 males on the overall 9-person team, and there are 4 females on the overall 9-person team. So in just trying to select our males, we have 5 to choose from, and for this mixed competition, it's 2 and 2. So from those 5, we're only wanting to select 2. And again, you're either on the team or you're not on the team, so this is a combination, so this would be a 5C2. This is the number of different male combinations that can be made for the 2 males that are on the team. With the females, you have 4 to choose from, so your N value is 4. You're choosing 2 of them, so your R value is 2. And again, you're either on the team or you're not, so this is a combination problem, so it's 4C2. So for every pair of males that you can choose, you're also choosing a pair of females. So you're choosing males and you're choosing females. So this is the total number of ways to select a male pair. This is the number This is the number of ways to select a female pair. And because you need to do both of them, select the males and select the females, you need to multiply these together. So you would take the 5C2 and multiply it by the 4C2. Okay? And again, we could just use our calculators to do this, and 5C2 gives us a value of 10. So there's 10 different male pairs. And for every male pair, there is 4C2, which is 6. So for every male pair that you choose, there's 6 different females. So 10 times 6, which is 60. So there's 60 different teams possible. Okay, so there's another example there. Okay, let's look at another one. So here we have a planning committee is to be formed for a school-wide Earth Day program. There are 13 volunteers, 8 teachers, and 5 students. How many ways can the principal choose a 4-person committee that has at least 1 teacher? Okay, so a key word here to look at is the fact that it's at least. Okay, so this is a scenario where we have to break things into cases. Because if it has at least 1 teacher, here are the possible cases that we have. So in case 1, there's 1 teacher, and the other positions would be filled by students. Since it's a 4-person committee, there'd be 3 students on the committee. Case 2, using at least 1 teacher, 2 teachers is still at least 1. So you could have 2 teachers, and the other 2 spots filled by the students. In your third case, you could have 3 teachers on the committee and only 1 student. And your fourth case would just be a committee of all teachers, because 4 teachers fits that description of at least 1 teacher. And there's been no other requirement that says it needs to be at least 1 teacher and at least 1 student. Right? If that was the case, then we can eliminate case 4 altogether, but it's not in this case. Okay? So we have 4 cases. So when we do cases, remember that it's an or situation. It's either case 1, or it's case 2, or it's case 3, or it's case 4. So when we find the number of options for each of the cases, we're then going to add them up to get the total. So like we did in that last problem, you're kind of separating it as, okay, ways to choose the males versus ways to choose the females. And in this case, it's ways to choose the teachers and ways to choose the students. So in case 1, in order to choose the 1 teacher, how many teachers do you have to choose from? Well, we have 8 teachers to choose from, and we're only choosing 1. And the other 3 spots are going to be filled by students. How many students did we have to choose from? 5. And from that, we're going to be choosing 3. So the number of different possibilities for case 1 with 1 teacher and 3 students is formed by taking 8, the combination of just 1, or 8 choose 1, and multiplying it by 5 choose 3, which gives us a total of 80 different possibilities. Okay, now we look at case 2. Now we're putting 2 teachers on the committee. So again, how many teachers do we have to choose from? 8. How many of them are we choosing? 2. Right? And now we have to break it up into students. So the other 2 spots are going to be from our students. From our students, we had 5 to choose from, and we're only choosing 2 this time. So now we calculate 8 choose 2 times 5 choose 2, which gives us 280 possibilities of a 2 and 2 committee. In case number 3, we're choosing 3 teachers and 1 student. So again, there were 8 teachers to choose from, and now we're choosing 3 of them. And there were 5 students to choose from, but we're only putting 1 on the committee. So this is again 8 choose 3 times 5 choose 1, which gives you, again, 280 options. And finally, in case 4, we're just putting 4 teachers on the committee. There were 8 to choose from. We're choosing 4. From the 5 students, we're choosing none. And what we end up with is 8 choose 4 is 70, and 5 choose 0 would actually just be 1. There's only one way to put 0 students on the team, or on the committee, so my option here is 70. Okay, so because these are cases, it's an or scenario. It's either case 1 or case 2 or case 3. So now we just take the sum of all the cases. So it's 80 plus 280 plus 280 plus 70, giving us a total of 710 different committee options, right? And again, this is a combination problem because you're either on the committee or you're not. We're not electing positions. It's not like how many ways there are to make a 4-person committee of a president, a vice president, a secretary, and just a rep, right? That would be a permutation because then the order matters because the position also matters. But in this case, it's just a combination. You're on the committee, you're not on the committee. So in this case, you have 710 ways to do that. Okay? So those are your examples on combinations. Right, and these would be some excellent practice problems to take a look at. And again, the best way to get better with these types of questions is to do as many as possible and become familiar with how they're worded and situations that fit with combinations versus permutations.